Welcome to an introduction to logarithms. The goals of this video are to define a logarithm and convert exponential equations to logarithmic equations and vice versa. So the first thing I want to talk about is, what is a logarithm? Well, a logarithm is just an exponent. So if someone asks you that, now you have the answer. Let's take a look at a more formal definition. Log base a of x equals y means a to the power of y is equal to x. So since a logarithm is an exponent, it should seem logical that we can write a log equation as an exponential equation. Notice a would be the base, y would be the exponent, and x would be the number. We could say that y is the power which we raise a to get x. And we should note that a has to be greater than 0 and a cannot equal 1. So if we have log base 2 of 8 equals 3, this means 2 to the power of 3 equals 8. And a nice way to remember that is just start with the base and kind of go around the circle. 2 to the power of 3 is equal to 8. And we can use this definition in the opposite direction as well. If we have 5 to the second equals 25, we can rewrite this as a log equation, where we'd have a log, the base is equal to 5, the number is 25, and this must equal 2, since 5 to the second equals 25. We'll come back to this idea later, but let's go ahead and talk about common log and natural log, because these are the two logs that you'll find on your calculator. The logarithm with base 10 is called the common log. This is the log key on your calculator. So you won't see common log written like this. If it's base 10, we leave the base off. So if you have your calculator, you'll notice a log button here on the left side. So if I press log 10,000, this is equal to 4. Let's go ahead and write that down. And if I asked you, why is log 10,000 equal to 4, you should be able to tell me that, oh, this is common log, which means that's base 10. And so what this means is 10 to the power of 4 must equal 10,000. So it's great to use the calculator to evaluate common log, but I think it's important that you understand what you're finding. Notice you're finding the exponent for which you raise 10 to get the number 10,000. The second log the calculator has is the natural logarithm. The logarithm with base e is called the natural logarithmic function. This log is also on your calculator as capital L, capital N. So you won't see log base e of x. It's written ln x. So you have to remember that this just means log base e. Remember, e is an irrational number similar to pi, except it's approximately equal to 2.718. So for example, if we type in natural log of 95 on the calculator, here's the natural log key, we're going to get a decimal approximation. It's approximately 4.5539. So what does that mean? Remember, natural log means log base e, so that means e to the power of 4.5539 is approximately equal to 95. We did round this, we won't be exact, but let's go ahead and check it. So if we press second natural log, it brings up base e. We can just type in our exponent, and you can see it's approximately 95. Let's go and take a look at a few more examples. Let's take these logarithmic equations and write them as exponential equations, which means we're just going to rewrite these using the definition of a logarithm. So here's the definition, but if you can just remember to go clockwise around the equation, 2 to the third must equal 8. The nice thing about going from log form to exponential form, you can check it. This is true, therefore it's correct. Here we'd have 3 to the power of negative 2 equals 1/9. That's correct. Here's natural log, so that would be base e. It might be helpful to write that in. E to the first power must equal e. That's correct. And then another common log, recognizing this as base 10, 10 to the power of 3 must equal 1,000. And let's go ahead and take a look at a couple more in the opposite direction. We want to write these exponential equations as logarithmic equations. So on this first problem, we know we're going to have a logarithm. So there's three key components: the base, the exponent, and the number. Well, the base is 4 down there in the basement. You can think of it being in a lower position. A logarithm is an exponent, so the exponent is 3, the log must equal 3, and the number is 64. Again, 4 to the power of 3 equals 64, and it checks. The third one, again, we're going to have a logarithm. Here it's base 10. A logarithm is an exponent, so the exponent is -2, the log is equal to -2, and then the number is 100. Now, there's one more thing on this one though. It is a common log, so it's not wrong to put this base 10 in there, but you'll very seldom see it, so I'm going to go ahead and erase that. Remember, if the base isn't there, we know it's common log. And the last one, it's a logarithm. It'll have a log. Now it's base e. Again, a logarithm is an exponent, so it must equal 2. And the number is approximately 7.389. Now in this one though, we have log base e. We can't leave it in this form. We should rewrite this as natural log 7.389. So this would be our intermediate step, but we want to leave this as our final answer. Okay, now you might be asking, what's the big deal with logarithms? Well, there are a lot of logarithmic scales used in real life. Three of the most common ones are the Richter scale to measure the intensity of earthquakes is a logarithmic scale. A decibel scale to measure sound levels is a logarithmic scale, as well as the pH scale to measure how basic or acidic a substance is. That is also a logarithmic scale. So if you search any of these online, you'll notice that they all involve logarithms. Okay, so this is the first of several videos on logarithms. I hope you found it helpful. Thank you for watching.